Good day everyone. So today we are gonna be solving problem 7.5 from the book Mechanics of Materials, 4th edition by Beer and Johnston. So for the problem 7.5, it is given as for the given state of stress, determine A, the principal planes, and B, the principal stresses. So for our given, we have the normal stress of x-axis is equals to 63 megapascals. Normal stress of y-axis is equals to negative 42 megapascals. And shear stress of x and y-axis is equals to 28 megapascals. So, if you are wondering why some is positive and why some are negative, it is because we are following the sign conventions given by the book. So, in solving the principal plane of the problem, we first have to know that the principal plane formula. So the principal plane formula is given by the equation tan 2 theta is equals to 2 tau xy over sigma x minus sigma y. So tau xy is the representation of the shear stress, while the sigma x minus sigma y is the representation of the normal stresses. So now that we know the formula for the principal plane, we now use the given that we have obtained earlier and substitute them to the formula, or input the given variables to the formula. So it will be given as tan 2 theta is equals to 2 times 28 over 63 minus negative 42. So in calculating this, we get tan 2 theta is equals to 56 over 105. Now multiplying both sides of the equation by tan inverse tan or arctan, we get 2 theta is equals to 28.07 degrees. So for us to get the final answer, we divide 28.07 degrees by 2. And here we get the principal plane, which is equals to 14.035 degrees. And in case you are wondering where we got the 104.035 degrees, we just added 90 degrees so that we will get the another orientation for the principal plane. In case you are wondering why we added 90 degrees to theta on our principal plane, it is because the difference between the two theta is 90 degrees. Therefore, we added 90 to our final answer, 14.035, which turns out as 104.035. Moving on to our letter B of the problem, for the second part of our problem, we must first recall the formula of the principal stresses. So the principal stresses formula is given by the equation theta maximum or minimum is equals to sigma x plus sigma y over 2 plus minus square root of sigma x minus sigma y over 2 squared plus tau squared of x and y. So moving on, we still have the given variables that we have obtained from earlier. Sigma x is equals to 63 megapascals, sigma y is equals to negative 42 megapascals, and tau xy is equals to 28 megapascals. So by substitution of the given variables to the formula of the principal stress, we get 63 plus negative 42 over 2 plus minus square root of 63 minus negative 42 over 2, square the value, then plus 28 squared. So after simplifying this equation that we have for the maximum and the minimum, we get the final answer, which is 10.5 plus minus 59.5 megapascals. So in case if you are wondering how we get the maximum theta and the minimum theta, we simply add the 59.5 to the 10.5 or minus the 59.5 to the 10.5. So by performing the operation, we get the maximum principal stress of 70 megapascals and the minimum principal stress of negative 49 megapascals. Now, what does this result tell us? It tells us that 70 megapascal acts on a plane defined by 104.035 degrees and negative 49 megapascal acts on a plane defined by 14.035 degrees. So that would be all for today. Thanks for listening, and once again, have a great day.